Epicon tutorial.
Good day, listeners. We want to solve this initial value problem, that is highly nonlinear by differential transform method. So the first thing, as we have been doing in the past, is to first transform the differential equation. So this can be transformed. The second order can be transformed as k plus 1, k plus 2, k plus 2 minus the nonlinear part can be transformed as n from 0 to k minus n plus 1 y of n y of n y of k minus n plus 1, then plus a second nonlinear term can also be transformed as n equal to 0 to k y of n y of k minus n. The initial conditions will be transformed as we have y of 0 equal to 0, y of k equal to 0. At k equal to 0, we have y of 0 equal to 0. Then the second one, y prime of 0 equal to 1. So this will be k plus 1, yk plus 1 equal to 1. At k equal to 0, y of 1 equal to 1. So solving for y of k plus 2, so we have y of k plus 2 will equal to 1 over k plus 1, k plus 2 into summation n from 0 to k, and then we have k minus n plus 1 y of n y of k minus n plus 1 k minus n plus 1 minus summation n equal to 0 okay. Have a y of n k, so this will be y of k minus n. So we begin the solution at k equal to 0. So when k is 0, n2 is 0. So that means we're going to be having y of 2 equal to 1 over 2 here into, since both k and n are 0, so it's going to be 0 minus 0 plus 1, y of 0 minus 0 plus 1 minus y of 0 minus 0. So this one gives us y of 2 equals to 1 over 2 into 0. This will give us 1. Half 1 multiplied by y of 0, y of 1 minus y of 0, y of 0. So if we simplify this, we discover that our y of 2 is equal to 0. Then quickly, when k is 1, n runs from 0 to 1, because in our summation here, we say our n is from 0 to k, and since k is 1, so we're going to be having n equal to 0 and n equal to 1, and such will be substituted here. So what we're going to do now is that since there are two values of n, so we'll first of all substitute the values of n and then later impute the value of k. So our y during our when k is 1 is going to be 1 over 6 into k minus 0 plus 1, y of 0, y of k minus 0 plus 1. Then we have for n equal to 1 plus 1, y of 1, and y of k minus 1 plus 1. Then for the second non-linear term, so we're going to have y of 0, y of 1, k minus 0 plus, when n is 1, and then k minus 1. So we have imputed the values of n when it is 1 and when it is 0. So now let's introduce the values or the value of k. So that would be 1 minus 0 plus 1, y of 0, y of 1 minus 0 plus 1, plus 1 minus 1 plus 1, y of 1, y of 1 minus 1 plus 1. Then for this second one, we have y of 0, y of 1 minus 0 plus y of 1, y of 1 minus 1. We have a y of 3 equal to 1 over 6 into, this will give us 2, y of 0, y of 2 plus y of 1, y of 1, then minus y of 0, bracket y of 0, y of 1 plus y of 1, y of 0. So this will give us, of course, this will be 2, 0, y of 0 is 0, y of 2 is 0, plus 1. This will be times 1 minus, right, bracket here. Then this will be y of 0 is 0, y of 1 is 1, plus 1 times 0. So when we simplify this, our y of 3 will be equal to this times 1 over 6 into 0 plus 1 minus 0 plus 0. So which is 1 over 6. So briefly, we want to look at when k is 2. Our n will be from 0, 1, 2. So when k is 2, we have y of 4 equal to 1 over 12 into, so introducing the values of k and of n. So we're going to have k minus 0 plus 1, y of 0, y of k minus 0 plus 1, plus k minus 1 when n is 1 now, plus 1, y of 1, then y of k minus 1 plus 1. Then also when n is 2, k minus 2 plus 1, y of 2, y of k minus 2 plus 1, bracket closed here. Then the other one, 2. So we're going to be having negative minus this. So that will be when n is 0, k minus 0 plus when n is 1, y of 1, y of k minus 1 plus when n is 2, y of k minus 2. So introducing the value of k, we're going to have this time our k is 2, 0 plus 1, y of 0, y of 2 minus 0 plus 1 plus 2 2 minus 1 plus 1 y of 1 y of 2 minus 1 plus 1 plus 2 minus 2 plus 1 y of 2 minus 2 plus 1. Then the second nonlinear term. So have y of 0, y of 2 minus 0 plus y of 1, y of 2 minus 1 plus y of 2, y of 2 minus 2. So if we simplify this, it will form a pattern that can be easily predicted. 3y of 0, y of 3 plus 2 y of 1, y of 2 plus 1 y of 2, y of 1. And for the second nonlinear term, y of 0, y of 2 plus y of 1, y of 1 plus y of 2, y of 0. So if we introduce the values and simplify, y of 4 will give us 1 over 12 every term there. So we're going to having 3 times 0 times 1 over 6. That's our y of 3. Then plus 2 times 1, because y of 1 is 1, times y of 2 is 0. Then plus 1 multiplied by 0, multiplied by 1. Then for the second term, so we have 0, 0 plus 1, 1 plus 0 multiplying 0. So and this will yield 1 over 12 multiplying. So by the time we open the bracket for the second nonlinear term, only this will remain as negative 1. So our y of 4 will be negative 1 over 12. So bringing all your results together, so we say y of x equal to y of 0 plus x y of 1 plus x squared y of 2 plus x cube y of 3 plus x raised to the power 4 y of 4. And this will yield 0 plus x. Our y of 1 is 1. Our y of 2 is 0. Our y of 3 is 1 over 6. Our y of 4 is negative 1 over 12. So y of x finally gives x plus x squared plus x raised to the power 3 over 6 minus x raised to the power 4 over 12. So that is the solution of the differential equation. Thank you for listening.